All right, happy Thursday, guys. Miss Ross did not realize that the video of Miss Schaefer doing the study guide was not the same as the study guide that Miss Schaefer did is not the same as this study guide. It's very similar, but it's not the same. So I'm gonna do this with you very quickly. I do have a couple of kids in the room. I've got, let's see, there's 7 of them in here, and we are going to record this video and upload it as soon as possible for you guys at home. All right, which point on the grid is located at 6, 7? So I'm going to run to 6. I'm going to jump up to 7, and X is there. How did I find that? I ran 6 up 7. All right, easy enough on that one. There is that X coordinate right there. All right, what ordered pair identifies the location of the triangle plotted on the coordinate grid? How could you find its coordinates? All right, so here's the triangle right here. All right, so it is on the 16 line for the X, and it is on the 13 line for the Y. So it is 16, 13. I would run 16, jump 13. Let me double check that. 16 and 13. Yes, so I would start at the origin, run 16, jump 13. All right, describe the path needed to move from point A to point X. Point A is right here, and point X is over here. So what you would need to do is you need to jump up 1 and move over, go to the left 10. So you would go up 1 space, and then to the left 10 spaces. Okay, so start at A, jump up 1, and move to the left 10. All right, next one. Points A, B, C, and D make a rectangle. Which points have the same X coordinates? Which points have the same Y coordinates? All right, so what I want you to do is I want you to write the coordinates next to them. All right, so for A, the coordinates are 16, 6. Write it out next to it. For B, the coordinates are 16, 3. I ran 16, I jumped 3. For D, I ran 21 and I jumped 3. And for C, I ran 21 and I jumped 6. Okay? All right. So which ones have the same X? It says here, which points have the same X coordinate? The X coordinates are the first numbers. So which coordinates have the same 2 first numbers? Well, A and B both have 16 as their X coordinates. So come up here and write A and B. Which points have the same Y coordinates? Well, the ones that have the same Y coordinates. Oh, wait, I missed something up here. So A and B have the same X, and also C and D have the same X, right? Then down here, for the Y coordinates, those are the second numbers because you've got X and Y. So for the Y coordinates, B and D both have 3. And A and C both have 6 as their Y coordinate. All right, name a point that could be found within the area of the rectangle. So here is the rectangle, all right? And here are the points that are within inside of it. You've got all of these inside of there. There are 8 inside of it. I'm not going to count the ones that are on the line because that's not inside, okay? So name any point that could be inside the area of this rectangle. I'm going to go for 18, 4. Run 18. Jump 4, and I am solidly inside of that rectangle. All right, how would you graph 4, 8 in the first quadrant of the coordinate plane? Well, always start at the origin, run 4 and jump 8, and then there you would be. So write that down. Start at the origin, then go right 4 up 8. All right. Sally graphed 5, 2 on a coordinate grid. Given the rule, take X x, subtract y, name 3 more coordinates. Now this is one of those ones where you have to make a t-chart, okay? So I've got x and I've got y. Her first coordinate is 5, 2. And the rule is take the x number and subtract 3 and you'll get the y number. So if her x number is 6, subtract 3 to get her y, and you get 3. If her x number is 7, the rule is x subtract 3, her y will be 4. If her x number is 8, and you subtract 3, her y number would be 5, okay? So here are our next coordinates. You would have 6, 3, 7, 4, and 8, 5. All right? You need to make a t-chart for those. All right, write a question that would be represented by a line graph. What type of data would you collect? Okay, so we talked about a line graph. A line graph is one of those ones where it goes up and down, and it shows change over time. So let's write change over time. That is line graph data. And remember I talked to you about how we could graph Miss Ross's weight. Miss Ross's weight. At Christmas it goes way up. And then in the springtime it comes down. Okay? Miss Ross's weight over time. Okay? Those are the ones that look like this. Okay? Those are line graphs. Next one, write a question that would be represented by a line plot. Line plot is when you have the little X's like this, okay? And down here across the bottom, you'll have numbers, okay? So this is numerical data. So this would be things like how much, how many, right? How much, how many. Okay, those would be line plots. Number 9, write a question that would be represented by a bar graph or a pictograph. Okay, so those are the ones where you have names across the bottom. So my favorite food is Mexican. How many kids like Chinese food? How many kids like American, just like, you know, good old McDonald's? Okay, and you would have bar graphs that would show the amount of kids that like these things. These are names across the bottom. They are categories. This is called categorical data. You will have questions on these on your test. All right. If the pattern in the chart continues, how many more vanilla scoops than chocolate will be sold on day 8? Okay. The problem that we have here is that this chart only goes to day 4, all right? And we need it to go all the way to day 8. So let's come down here, and I want you to write 8, 9. No, sorry, my bad. Don't write 8 and 9. Sorry. I don't know where I was thinking. Write 5, 6, 7, 8. And then we're going to extend the chart down here. Okay, but first we have to find out the rule that it's following. So for chocolate, it goes 8 to 12, 12 to 16, 16 to 20. It's going up 4 every time, right? So let's do that. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 for day 5 is 24. Then for day 6, we've got 28. And for day 7, we've got 32. Then for day 8, we've got 36. All right? Now, we got to do the bottom. 16 goes to 18. 18 goes to 40. 40 goes to 52. So for the vanilla, it's going up 12 every time. Okay, so we have to continue all the way to day 8 by adding 12. 52 plus 12 is 64. 64 plus 12 is 76. 76 plus 12 is 88. 88 plus 12 is 100. Now, make sure you answer the question. How many more vanilla than chocolate will be sold on day 8? So you take 100, you subtract the 36 chocolate, and you get 0, 9, 10. You get 64. Okay, there will be 64 on this date. All right, next one. A fish store sells 8 guppies a day. A different store sells 3 guppies a day. What is an order that shows how many are sold after 5 days? So always make a T-chart. So I've got let's see, the first store. So I'm going to put S1 is store 1, and then S2 is store 2. All right, the first day, store 1 sold 8, store sold 3. That's day 1. Let's go to day 2. Day 2 would be 16 for this one because 8 plus 8 is 16. Add 8 again, you've got 24. Add 8 again, you've got 32, and we're going all the way to 5 days. 32 plus 8 is 40, okay? 8, 16, 24, 32, 40. Day 1, day 2, day 3, day 4, day 5. On the bottom, you're adding 3 more each day. So 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. So your ordered pair for day 5 is 40, 15. Flip to the back. All right, here we go. This table shows the first 5 terms in 2 number patterns. So these are just terms. They're not part of the pattern, right? All right, so this goes from pattern 1 is 3, 6, 9, 12, 15. So that's a plus 3 pattern. Pattern 2 is 2, 4, 6, 8, 10. That is a plus 2 pattern. Oh no, here's that word that my husband hates. Relationship. He does not want to hear about my daughter's relationships with anybody because he imagines them side by side holding hands. Okay? We have to determine the relationship from 3 to 2, from 6 to 4, from 9 to 6, from 12 to 8, from 15 to 10. What is happening every single time? Okay? You have to determine the relationship. Okay, so what I see happening is, let me think about this. It's subtracting 1 more. Is that correct? I'm trying to figure out what that would look like. How would I say that? So what is happening every time is that pattern 1 is subtracting 1 more than the time before. So here it subtracts 1, here it subtracts 2, here it subtracts 3, here it subtracts 4, and here it subtracts 5. So what is the relationship is that it subtracts 1 more each term. Okay, so from 3 to 2 it subtracts 1. From 4 to 6 it subtracts 2. From 9 to 6 it subtracts 3. From 12 to 8 it subtracts 4. And that is the relationship. All right, 2 patterns were created. Pattern 1 adds 6. Pattern 2 adds 4. Draw a table that would represent those patterns. So draw your table here. And this is pattern 1 and pattern 2. Pattern 1 adds 6. So you've got 6, 12, 18, and you can stop at 24. Pattern 2 adds 4. 4, 8, 12, 16. Okay, and that answers number 13. All right, write a rule for this table. So when you're talking about a rule, you're talking about the relationship. What is happening from the rooms to the puppies, from the rooms to the puppies, from the rooms to the puppies. In 1 room, I have 4 puppies. In 2 rooms, I have 8 puppies. In 3 rooms, I have 12 puppies. So this is a I am taking this number and I'm multiplying it by 4 to get the puppies every time. 2 rooms times 4 gives me 8 puppies. 3 rooms times 4 gives me 12 puppies. So the rule is this. 3 times the room equals P for the puppies. You could also write this just 3R equals P. 3R means times the room. All right? All right, Donnie and Marie are counting people. I want you to cross this one out. I despise this question. I think it's terrible. We're not going to use that one. Okay? It doesn't work out to have a good relation. It doesn't show a good corresponding relationship, so I don't like to use it. Now, for number 16, we are going to write a statement about the data on the graph. Okay, so what we have here is it says years. So we know already this is a change over time graph, okay, and it says baseball tickets sold 1990, 92, 94, 96, 98, 2000, 2002. So it's going up by 2 years, but in between 1991 and 1992, 1990 and 1992, 1991 is right here. Between 1992 and 1993, 1994, 1993 is right there. So these have numbers in between them. And the same way here, even though the scale is going up by 2 from 30 to 32, in between is 31. All right, so what are we looking at here? We've got baseball tickets sold, and then this is over years from 1990 to 2002. And then on the number side, it is the number of tickets in thousand. Well, thank goodness that they didn't just sell 30 tickets. That would be a very lucrative franchise, wouldn't it? But in the 1990s, they sold 31,000 tickets. Okay, so we're going to write a statement about this. So from 1990 to 2002. All right, so let's look at 2002. In 2002, they sold 41,000 tickets. Write that down because it's in between. I went to 2002. I came up here, and that's in between 40 and 41. 40 and 42. So that's 41,000 tickets. Well, let's look at 1990 when they started. In 1990, they sold 31,000 tickets. So over this 12-year period, they increased their profits by selling 10,000 more tickets than they did the first year. So write that. Over 12 years, they sold 10,000 more. All right. In which 2 years were the exact same amount of tickets sold? If I'm looking on here, the only ones that it's the exact same amount is 1991 and 1992. Because not 1990 and 1992. Because 1990 sold 31,000, 1991 the exact same amount. I apologize about that. And you can tell that they're the same because they're side by side. In what year were the most sold? Well, in that final year there, so that's year 2002. In 2002, 41,000 were sold. In what year was the least sold? Well, in the year that they started. So that was 1990. Or 1991 is also low. All right, so what happened to the number of tickets sold between 1999 and 2002? So I'm going to come here to 1999. It's right here. And 2002. 2002 is right here. So from here to here, it went up. There was a positive increase. It went from 38,000 to 41,000. So it went up $3,000 in that amount of time. Okay? It increased by 3,000. Okay, so now I'm going to try to send